There must be a reason why we prefer to use polar aprotic solvent for an SN2 reaction. So, SN2, remember, is being favored by a primary alkyl halide. Recall the mechanism. There's only one step. Incoming nucleophile will kick out the leaving group at the same time. So let me just provide one example for you, then we can consider better why polar aprotic solvent is good for SN2. So again, let's use chlorine as a leaving group. Okay. Now, we notice that SN2, there's only one step. So the driving force comes from the strength of nucleophile is going to be very strong because you need to come in from the back of where the leaving group is and remove this chlorine. But as you know, a nucleophile that's strong should have negatively charged, such as hydroxide, cyanide, among the rest. Then you think about it, can you really buy a solution or have a solution or mixture or solid that is purely negatively charged? You can't, because they do not exist a bottle of hydroxide that's being sold or a bottle of cyanide. It always comes with a counter ion, in fact a cation. So normally you find them with K plus or Na plus group 1 metal ions. They are not very reactive, they are inert in nature. So it doesn't matter which cation you use, in this case, because they're group 1, they're always soluble, but when you dissolve in a solvent, they will just dissociate. So we have separated potassium ion that we do not need and the hydroxide ion, which is a nucleophile. Now, if we use a polar protic solvent, like alcohol, let's use ROH, that has hydrogen bonding. So delta minus, delta plus. If we use this solvent, which is polar protic, for such a reaction using a hydroxide as my nucleophile, what happens? Then this hydroxide nucleophile, negatively charged, could be surrounded by many of these solvents. Remember, solvent, they must be excess in nature. That's why you say solvent dissolve your solute. So this can form hydrogen bond. And not only that, you can also form another one over here by another molecule of your solvent. So what happens is, right, you have more of these solvent molecules that surrounds your nucleophile, which is supposed to attack this substrate. So as if you form a cage around it. You form a cage around this nucleophile such that it is heavier, it's a bit immobilized, it cannot use its electron density, in particular the lone pair, to attack this carbon that's hidden inside. Which means it won't be effective. As an SN2 reaction, it can't kick out the leaving group. But if I'm going to use a polar aprotic solvent, so this cannot surround the nucleophile site, the lone pair, because there's lone pair that's repulsive. They won't form a cage. So it is good. In fact, it has one more advantage. This lone pair here of this solvent that's aprotic can surround the cations. You see? I can draw one more here. Right, and I can draw another one. The lone pair can surround the cations such that it will pull away this K plus or Na plus and release the free nucleophile, the hydroxide. Then it can attack this substrate, the alkyl halide, and kick out the leaving group, make the reaction possible. So that's the reason why in SN2 we prefer to use a polar aprotic solvent. Just like other chemistry parts, not sure, just try both ways and then you see the difference, the effect.